scientist collects 0.24 mole of a hydrogen gas in a balloon. The temperature of the hydrogen is 35 degrees Celsius and the pressure in the balloon is 1.05 atmospheres. What is the volume of the balloon? Our ideal gas law formula is PV, or pressure times volume, equals nRT, which is the number of moles, times the ideal gas constant, times the temperature in Kelvin degrees. Okay, so what we're going to do, we're going to get the V, since we're looking for volume, we're going to get the V by itself. We need just this. Got to get rid of that P. It's being multiplied by the V now, so I'm going to divide both sides by the pressure. And so now my new formula is volume equals nRT divided by P. So I'm just going to plug these in. For N, I'm going to put the number of moles, which is 0.24 moles. And for R, we're going to use the ideal gas constant that relates to atmospheres. You've got to look and see if yours is in kilopascals or atmospheres. Since the problem is the pressure is in atmospheres, we're going to have to use this R, okay, which is 0.821 Whether or not you write down all of those units, it doesn't matter. I'm going to go ahead and write them down just to make sure everything cancels. Liters, atmospheres, and that's divided by mole, Kelvin. Okay, and then the temperature, but it's got to be in Kelvin degrees always. So to convert, let's look at this. To convert from Celsius to Kelvin, they give us 35 degrees Celsius. We have to take 273.15 and add 35 to it. 308.15 Kelvin. And then I'm going to divide that by the pressure, which is 1.05 atmospheres. I'm going to take a quick look at my units and see if everything cancels. Moles over moles cancels. Atmosphere over atmosphere cancels. Kelvin over Kelvin cancels. So we're left with liters, which is good for our volume. And that's what they want the answer in, is in liters. So when I get my calculator out, grab a calculator, use one on your phone, pull one up in another tab if you want to from Google. I'm going to multiply 0.24 times 0.821 times 308.15 equals divided by 1.05 equals. And I get 57.8. And my final answer is 57.8 liters. Okay, here's another ideal gas law problem. A 75 milliliter light bulb is filled with neon. There are 7.16 times 10 to the negative fourth moles of gas in it, and the absolute pressure is 116.8 kilopascals after the bulb has been on for an hour. How hot did the bulb get? First thing we have to decide is, what are they asking us for? They asked us, how hot did the bulb get? Which one of these could that be talking about? Pressure, volume, number of moles, gas law constant, or temperature? Well, it's talking about temperature. So let's put the formula down. PV equals nRT. We need to solve for T only. Okay, so we got to get rid of the N and the R. So I'm going to divide both sides. Since they're being multiplied times the T, I'm going to divide both sides by NR. The NR's go away on the right side, leaving me T equals PV over NR. So the pressure is going to be equal to 116.8 kilopascals times the volume. That volume needs to be converted to liters, okay? 75 milliliters is going to be 0.075 liters because there are 1,000 milliliters per liter. So if I was to write that down, 75 milliliters divided by 1,000 milliliters per liter. My milliliters cancel. Liters are under two divisor lines, so that liters comes back to the top, leaving me 0.075 liters. All right, the N, the number of moles. It's a very tiny number, very few moles in this light bulb. 7.16 times 10 to the negative fourth moles of gas, and we're multiplying that by the gas constant. Now this time we are going to, our pressure was not in atmospheres, it was in kilopascals, so we need this one, okay? So we're gonna multiply that by 8.314 liter kilopascal divided by mole Kelvin, which is like crazy big long unit, but it all cancels out. Kilopascals cancels out, liters cancels out, moles cancels out, leaving you the temperature in Kelvin. And they asked for it in Kelvin right here, so that's good. Okay, so when I put this in my calculator, $116.8 multiplied by 0.075 liters, and I'm going to multiply the top first. And I get 8.76. And then I'm going to multiply the bottom. Make sure you know how to enter scientific notation on whatever calculator you're using. I'm using a TI 30X Roman numeral 2S, and when I do this, and I'll say what I'm entering as I enter it, but if your calculator's different, it may have to be entered different. I'm going to use open parentheses, 7.16 times 10. Then I'm going to use this little up arrow on the far left and enter the -4, close parentheses, times 8.314 equals. And I get a super long number, 0.0. It's really a long number, but it's tiny, less than 1, 0.00595. I'm just going to stop there. The next number is 2. I'm just going to keep it there, okay? And then I'm going to divide 8.76 divided by 0.00595, enter, and I get 1,472 Kelvin as my final answer.